What's good, everybody? Teacher Ty back at it. We're going to get into the Fab Four: addition, subtraction, multiplication, and division. I'm going to put these videos and the one I did with my granddaughter over the holiday weekend and yet another channel. I'm going to call it Alternative Math, kind of working title. Um, Not necessarily for students, although they can by all means get something from it. But if you have an issue with math or something on the subject, there'll be some videos there that can help you out. Also, if you need any help with something, drop a line or anything, and I can help you with it and put the video on there. So anything that has something to do with math, but not necessarily the standard, will be in the playlist for alternative math. And if you look real closely, you might see some changes. That's one of the biggest things with the subject. You get your syllabus the first day of school, at least for the 7 years I taught. You need to multiply, you need to add, you need to find derivatives. Hell, all that is true. But I would implore to you the number one thing to help you with this subject is to be able to spot patterns. When they happen, when something happens repeatedly or over and over, and when the patterns break. If you could do that, that's the crux of the subject. So, if you're not a seventh grader or an 11th grader going into algebra 1 or pre algebra, sixth grade math, any of that, look in on the playlist. And if you have a student in those grades, by all means, look in on them. And then look in on alternative math and tell me what you see, or maybe don't see. This is something I decided to do. So this first one is going to be about addition and subtraction. Addition, not too long. A little bit more on subtraction because that is a bit of a bugaboo with students and most people in particular. You'll see it when you get change for a purchase. If you've ever tried to give the exact change or sometimes not give the exact change and you see an employee at the register doing their damnedest to not mess this up. So we'll help you with that. Now the addition part won't be too long. For some of the time spent on addition, I'm going to show you place value while we say these words when we say these numbers. So this one's about a 6 today, especially on the subtraction. But I've got 2 steps for that. If you do 2 steps, the subtraction could be a little bit easier. Let's go ahead and jump in. Feet first, not head first. All right, so I'm going to jump into addition and subtraction. And again, we won't do too much on addition. And in its place, we'll work on place value a little bit. Again, why we say the words that we say when we say these numbers. For instance, this number right here, which reads 350,419. We have numbers grouped off together in lots of 3. And we do that because they have a name. For instance, this group right here, the 419, is called the ones. And that's everything from 1 to 999. This next group is called the thousands. And everyone from thousands on makes sense. This one might not because it's not a million or a billion or a trillion or a quadrillion. It's the ones, but that makes sense because it has literally the ones, the 10 times ones, and the 100 times ones. Now, to that end, and because we use something called base 10, that means we have 10 symbols in our math lexicon, and they are basically 0 to 9. These are the 10 numbers we'll use for the rest of our life. When we, like in this line right here, well, after that, we've got to do something else. Well, we use the next symbol, which would be 1, and then we reset this back to 0. So, this is the ones place, the tens place, and the hundreds place. And those three numbers, ones, tens, and hundreds, are the same for every group. This is 1, 10, and 100,000. We had three more numbers that'd be the ones, tens, and 100 millions. And then the ones, tens, and 100 billions. And then the ones, tens, and 100 trillions. And then the ones, tens, and 100 quadrillions. And you can go to a spot, and I can help you with it if you like big numbers, which I do. I love them. And if you look on that Math Matters little banner that I have, you might not know it, but there's one number on there that's got 67 digits. And I didn't write them out, but it's a shorthand way of doing that. But every group of numbers, the millions, the billions, the trillions, the quadrillions, the quintillions, the sextillions, the heptillions, the octillions, the nonillions, the decillions, all of them has 1, 10, or 100. And then you go to the next word, and it has 1, 10, and 100 of those. So, when you look at this number here, now, the rub is we're reading it from left to right, and I just explained it to you from right to left. So, you have to kind of decipher that at the same time. We read this number 350,419. But I said this was the ones, the tens, the hundreds, etc., etc. Both are true. So, let's look at it like this. Again, each number to the left is 10 times bigger, or the group, each number to the left in that group is 10 times bigger than the one to its right. For instance, I'm going to do here without the zeros. The ones, that is just 1 times 10 to the 0th power. Stand by on that lesson on exponents. Just know that any number, I stand by on that one because that'll be algebra. When I say any number and I use a letter, that's just because we don't care what the number is, so it could be every number. But some number to the 0th power equals 1. Stand by for that lesson. So this is 1 times 10 to the 0th power. That's 1, and we've got 9 of those. This is 1 times, well, I should say 9 times 10 to the 0th. 10 to the 0th power is 1, 9 times 1 is 9. And then we have 1 times 10 to the 1st power. Well, another little short lesson on exponents. Take this number, write it that many times. Well, okay, that must be 10, right? We have 110. This 4 is 4 times 10 to the 2nd power. Again, take the number, write it 2 times, and multiply. 10 times 10 is 100, and we have 4 of those. This is 0 times 10 to the 3rd power. Well, 10 to the 3rd power is take this number, write it that many times, write it 3 times, 10 times 10 times 10. This is 100. 10 hundredths is known as 1,000. And the letter K is known as 1,000 too. So don't get too confusing here. How many thousands do we have? How many 1,000s do we have? We have 0 of them. Next one, we have 5 times 10 to the fourth power. Take this 10, write it 4 times, and multiply. 10 times 10 is 100. 10 times 10 is 100. 100 times 100 is 10, oh crap, 10,000. Or we do 10, 100, 1,000, 10,000. Or we just write the number 1 and write that many zeros. 1, 2, 3, 4. 10,000. How many of those we have? 5. Next one is 3 times 10 to the fifth power. We can write a 1 and that many zeros. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Or we can multiply 10 times itself 5 times, which would be 1, 10, 100, 1,000, 10,000, 100,000. This is 10 to the first power, second power, third power, fourth power, fifth power. We give the scientific notation and all that. You'll be needing to know that. Okay, so let's take a second on this for place value. I've started on the 6th grade and 7th grade a little bit. I'm going to start on 8th grade here later on today. The 7th grade had to start with numbers, and numbers fit in these boxes, and there's 4 of them. There's actually 5, but 4 of them fit inside of each other, and one of them just sits off by itself because it's not like the other 4. Kind of like the Sesame Street thing, 3 of these things belong together. Well, there's a box of 4, there's a box in a box, which is in a box, which those 3 are in a box, meaning that the smallest box and the numbers in that smallest box are in all 4 boxes. All that to be said, that 0 is what's known as a placeholder. So if you don't have any, in this case, if you don't have any 1,000s, you can put a 0 there. Because we just can't put nothing there. If you just took the 0 off of that, then you have a different number. We're not talking about the number 35,419. We're talking about the number 350,419. So there had to be a symbol again in that base 9 symbol, base 10 math that we use. There had to be a symbol for nothing. And with these 10 symbols, this is the symbol for nothing. And again, when we get into math a little bit more, especially in this case, exponents, because you can have a different base, like maybe base 4. In base 4, you'll count 10, 11, 12, 20, that's 0, 20, 21, 22. But in base 4, you don't have any 3s. You don't have any 4s in base 4. So, all that being said, we'll might even get into bases. They might do that in alternative math. So let's look at an addition problem. Again, won't be too big of a deal. And that's subtraction. That's the next piece here. All right, so let's see here. All right, so with all that being said, let's look at an addition problem. And let's look at it from maybe a different angle here. The only thing you had to know about addition was to carry a number. If the answer is more than 10, then you carry the number over to the next group. And that's because, like in the case here, 8 plus 2 is 10. For one reason, we never write 2 numbers under the answer line. And we write until you get to the last set of numbers here. You never write 2 numbers here. And that, if I'm insulting your intelligence, I get it, but this is just explaining the rule to a T here. Since you never write 2 numbers, you write the last digit of the 2 numbers, And the first digit, which is another group of 10 higher, right, because we one digit to the left, it's always 10 times bigger, we carry that over to the other group. Again, we have 1, 3, and 9. When we add those up, that's 13. So since we don't write the whole number 13 down, we put the last digit of the answer in and carry that one over because it's 10 times as bigger. And then finish it out. So we got it from a different point of view. You can decompose the numbers in the problem. Maybe we'll have 5,000. And I'm going to use the letter K so I don't run out of space. We have 5,000 plus 4,000. Okay. We have 300 plus 900. We have 80 plus 20. I'm just using how many thousands do we have? 5. How many thousands do we have? 4. Add them up. How many hundreds do we have? 3. How many hundreds do we have here? 9. Add those up. How many tens do we have? 8 here, 2 here. So 80 plus 20. And then the last problem is 7 plus 2. Might be the easiest, but it's the one that doesn't have a number that isn't 0. So 7 plus 2, we've got that at 9. 80 plus 20, we've got at 100. And now you see why we have to carry. 300 plus 900 is 1,200. And you see again why we have to carry. And then 5,000 plus 4,000 is 9,000. So when we add those four numbers up, let me write those down here. I'll write the zeros in now because we're going to do the actual math. 1,200, we have 100, and then we have 9. The thing with this one is you don't have to carry until the last group. If you do it this way, you won't have to carry until the last group. So we have 9 plus a bunch of zeros. We have 3 zeros. We have 2 plus 1. And then the last group, we have 9 plus 1, and write it on out. And I would imagine that those numbers are equal. So, addition, just carrying. When you carry a number, since you can't write 2 digits in the answer, and because 2 digits, the left digit is 10 times bigger than the right one, that's why that number carries over into the next digit. Here, 80 plus 20 is 100. There's the 1, there's the 0, or 87 plus 22 is 109, right? There's the 1, there's the 09, right? 387 plus 922 is 1,309. And that 1 goes over there. So that is addition in a nutshell. That's low stress. Now, let's batten the hatches down because subtraction does get a little bit beefy here. Let's get it. All right. Are you all ready? We can do this, so let's go ahead and do it. The crux of subtraction, or taking away, is how to borrow. Borrowing is the carrying that you do in addition, or the opposite of that. So, as long as the number on the bottom of the problem is smaller than the number on the top, subtraction is just as easy as addition. We had 7 plus 2, and the addition problem here will subtract 2 from 7. Can you take 2 things from 7 things? Can you take $2 from $7? Yeah, and if you do, you have 5 left. But now, the problem is, can you take 9 things from 8 things? The answer, of course, is no. You cannot take 9 things from 8 things. So that's where borrowing comes in. As I said in the intro, there's a 2-step process for borrowing. Number 1, go to the left. You're going to go to the left and get 1. Now, your neighbor to the left will always say yes. Stand by on this problem because there's going to be an extra little kink in it. But your neighbor to the left will always let you borrow something. Like when we first moved here, didn't have a mower. My neighbor always let me borrow their mower. Now, I mowed their yard too for payment, but till we got our mower fixed, and I think we ended up having to get another one. Always said yes, and worked on it too, so kept the upkeep up. Now, your neighbor will always say yes, and they will give you that 1. But that 1, you're going to take it to the right where you couldn't subtract from and actually add 10. Remember, every number to the left is 10 times bigger, or the group that it's in is 10 times bigger than the one to the right. So since we can't take 9 from 8, we're going to go next door, and he only has 1, and he will give it to you. You know, you hear people say they'll give you the shirt off their back, they'll give you their last dollar. This neighbor will always give you 1, even if they have 1 left. So the question is, well, what do you do when you don't have 1? But we'll talk about that in just a minute. So they'll give you 1. If they give you 1 and only have 1, that means it goes down to 0. Has none there. This number now goes up 10, and it's 18. And what I do here is put this number in a circle, because I know that was a number that I just borrowed. I know it's 10 bigger than the number below it, so that helps too. Now, it's not 8 things there, there's 18 things there. And you can't take 9 from 18, that leaves 9. We're good. But now when we go here, we've got 5 things that we need to take from nothing. Remember, he only had 1, and he gave it to us over here. And that 8 became 18, so now he doesn't have any. Well, repeat the process. Go next door. That neighbor will always give you 1. If he had 3 to give, that means now he's only got 2. And if you do that successfully, this number will go up 10. Which means this is now 10. I'm going to circle it. I know it was 0, but now it's 10. 10 minus 5 is 5. I'm going to go here. We can take 1 from 2, so we don't have to borrow anymore. And besides, there's nowhere else to go. But 2 minus 1 is 1. And there we are. 1,595. And I was going to wait till the end of the video to say this, but if you're working with me now on this and you're not sure yourself, I get it. So, I don't know how your math teachers handled you over your school career, but at some point in time, they should have told you about something called inverse or opposite, but inverse operations. Inverse operations. Now, if you think about it, inverse means opposite, and the Fab Four I call, all 4 of them are operations: add, subtract, multiply, and divide. The thing is, addition and subtraction are inverses, and multiplication and division obviously are as well. This means that if you have a subtraction problem and you don't know or you're not sure the answer, you can always check that answer with the inverse operation. So in this instance, if you add 1595 plus 1592, you should get 3187. And if you don't, then this answer is wrong. But it's, of course, right, because I did it, but yeah. If you're ever unsure about a mathematic venture that you've done, there is an inverse operation that you can use to check. Equations, plug in the number that you found for the missing number. Subtraction, use addition. Addition, use subtraction. Multiplication, use division. So, now, I said there was a special thing here with this problem, and it's that 0 sitting right there. Now, cannot take 7 things from 6. So we're going to go next door and borrow one. But oh no, he doesn't have any. Well, that's odd. What do? We go 2 doors down. He does have one. So let's bring it down to 2. Whatever you use 1, that number goes down 1. This number goes up 10. But be careful, because we're not even on this number yet. We're still trying to take 7 from 6. Remember, we started borrowing here, but this number didn't have any. It's a placeholder. It's 0. We had no 10s. So we've got to take one of these 10, and bring it over here. Now that still adds 10 to that number, and that's now 16. And this number is now 9, because we had to take 1 from those 10. One more time. We could not take 7 from 6. Physically, mathematically, impossible. Can be done. Can't be done. So the 2 rules say go to the number to the left and get 1. Now that means that number will go down 1. Well, now he didn't have any to give. Still need something for this 6. So we got to go 2 doors down. He does have 3, so we can take one of those. That makes it 2. And this number would go up 10, except for the fact that we've got to take one of those, which means it's now 9, so we can put the 10 extra here. With that being said, we've got carrying all the way out to the second number from the right in the problem. But we do have our 16 now that we can take 7 from, and leaves 9. Here we have a 9 now, and there's subtraction. 9 on top is the best number, because 9 on top, we can subtract anything. And in this case, it's 3, so that leaves 6. And now, we have 2 here because of the double borrowing we did back at the beginning of the problem. That's fine, and we can't take 8 out of it. That's fine. We'll repeat the process by going next door, taking 1, and adding 10 to that number. This is now 12. Notice I didn't circle that 9 or the 10. And it was caught up in borrowing, but it's just a special situation there by having to go 2 spaces away to get the number that we needed. Anyway, we can bring 4 down to 3. We can add 10 to this 2. Remember, we gave 1 to them, and now we have our 12 here that we can take 8 from. That leaves 4. And then we have 3 minus 2, which is 1. So, carry with the number 1,469. If you're not sure of the answer, you can always take that answer, add 2,837 to it, and if you don't get 4,306, then this number's not right, but it is. This number's right. So if you're carrying and you've got a 0 on board, you just go 1 space to its left, or however many spaces it is until you can find a number that's not 0 and take 1 from there. And any numbers, any zeros you have there between when you had to start borrowing and when you finally run into a number that wasn't 0, just replace it with 9. You kind of almost circle that number, but it's up to you. We couldn't take 7 from 6. We went next door. They didn't have any, so we went a door down. They did. There's where the 2 came in, which became 10 because it was 0. It became 10, but since we had to take 1 to give to this number, it went down to 9. so that this could be 16. And we can subtract here. 9 on top of subtraction is heaven on earth because everything can be taken out of 9. We couldn't take 8 out of 2. So we did another borrowing session here, took 1, brought it down to 3. That means that was up to 12, which we can't take 8 from. And then 3 minus 2 is 1. Now, try it. Try some and make intentionally tough problems with smaller numbers on the top. You see I had smaller digits on the top and relatively larger digits on the bottom. 7's bigger than 6, 3's bigger than 0, 8's bigger than 3. Here we didn't do that. We had 7 minus 2 just to show you subtraction in its simplest form. Here, 9's bigger than 8, 5's bigger than 1. So try some numbers with smaller numbers on the top and larger numbers on the bottom and do those 2 steps. Go next door and take 1, take that 1 and make it 10 to bring over to the other number, and then you can subtract from it. You'll never bring a 2 over here. This will never be 26. You won't ever borrow 2. So you won't have any numbers. The only numbers you'll see here will be between 10 and 19, like 16, 9, 12. Here we've got 18 and 10. And it's only a special case where you'll have 9. So to be a little bit more accurate, be between 9 and 19. And I'm talking about these numbers on the top here. And 16, 9, 12, 18, 10. All right, so that's subtraction. Try it on your own. Try it. And intentionally try tougher problems until you can get it. But you didn't know this, but you can. You can do it. All right, so as a lesson on place value, addition, and subtraction, kind of low stress, but subtraction is kind of difficult, especially the borrowing aspect of it, and especially when you're borrowing and that number you go to borrow from is a 0. Just use the 2 steps, and if you have to go 2 or more numbers away, that's fine. And if it's a 0, just replace it with a 9. And a 9 on top of subtraction is the best thing in the world because every digit in the 10 numbers we use can be taken out of 9. So we're actually going to make it work for us. You want to try this in your personal life? Use it at the grocery store. Use cash. Use cash. When they tell you how much the total is, you give them a dollar amount, however many dollars is needed. See if you can come up with the change or the difference before the register does. It can be done because I did it my whole life because I was the one that had to go to the store for the family uh, at the warehouse market over on Fifth Street when that was warehouse market. But um, once you see the total, you give them the dollar amount, you should be able to see, what the change is. And beyond that, if you have somebody there, and unfortunately it's probably a younger person, you get it, they might be having trouble with it, especially if you give them a nickel or something to try to get a full bill back, and they kind of labor over the process. Maybe now you can help them out. The next lesson in alternative math is on multiplication and multiplication alone. To show you a process to where if you know what 9 times 9 is, there is not any multiplication that you can't do. And by the by, it's 81. But now, since you know what 9 times 9 is, there isn't 2 numbers in this planet you can't multiply, no matter how big, no matter how long, no matter how heavy. I'm going to show you how to do that next time on Alternative Math. Help a brother out with the like and subscribe. Tell your friends, tell your enemies, tell everybody in between. We're going to conquer math. We're going to do it together. See you in the next one.